Hi. Today I want to talk about protein synthesis. In our cell cycle, we have a four phase: M phase, S phase, G1, and G2. In our M phase, our cell will division. In our S phase, we have a copy of our DNA. So today I want to talk about what will happen in our G1 and in our G2. So in protein synthesis, it has two different steps: transcription and translation. So first of all, I want to talk about what's the meaning of transcription. Transcription means copy. So this is my cell, this is my nucleus, and this is my cytoplasm. My DNA in a stay in a nucleus, and transcription, it happens in the nucleus as well. So the problem is how we can get our information from the factory, from the nucleus out, because our ribosome in a stay in cytoplasm in here. So our DNA, it should stay here in nucleus because it should be safer for it. So for solving this problem, what can I do? So we can make a photocopy from our gene. Our DNA has a two side. The first side has the information on it, and we call template strand. The other one we call complementary strand. So let's make our template strand together. I already built it, but now I want to show you and explain for you how I built this one. So our DNA, in our DNA, we have adenine, thymine, guanine, and cytosine A, T, C, and G. I used two red lattice for it's represented our backbone here, and also colorful gummy as well. So my adenine or A, it shows with a green gummy here. My thymine or T, it shows with yellow. Our C orange, and G red. So, and also I should add this point. Our A, it always pair with G. A, it always pair with T. T pair with A. C pair with G, and G will pair with C. So it means if we have a A here in template strand, we should have a T in complementary strand. If we have a G here, we should have a C here. If we have a C here, we should have a G here. If we have a T here, we should have a here. So in here, for template strand, I use this code AGTACCATGCCAA and as I said before, A, it shows with green, G with red, T with yellow, A with green, C orange. In our complementary strand, green, it should pair with yellow, red, it should pair with orange, and yellow, it should pair with green, and etc. So, as I said before, our DNA, it should be stay in our nucleus. It means here, this is our DNA, this is our template strand, this is my complementary strand. So just 1 second. So this is my cell, and this is my nucleus, and this is my DNA strand, this is my template strand, this is my complementary strand. They stay in the nucleus when the DNA separate together like this. When our DNA separate together like this, we can make a copy from our template strand, and we can make our RNA. We have three kinds of RNA. We have rRNA, we have tRNA, and we have mRNA. And here we will use our mRNA or our messenger RNA. In our RNA, as I said before, in our DNA we have A, T, C, and G, but in our RNA, instead of have adenine, we have a uracil. It means we don't have adenine here. So in DNA, our A pair with T But here our A will pair with U because we don't have an adenine here. So let's make mRNA here together. I already built this one, but I want to show you. So this is my mRNA strand. Just make sure and don't forget, for making our mRNA, we should use our template strand, not complementary strand. So this is my template strand, this is my complementary strand, and this is my mRNA strand. For mRNA strand, in here, in our template strand, we have a green, we have A paired with U, A paired with U, because as I said, we don't have an adenine in our mRNA strand. We don't have an adenine in our RNA strand. But G will pair with C, C will pair with G, T will pair with A, just A, it will pair with the uracil. So our mRNA strand done, our copy of our mRNA strand done. When our copy of our mRNA strand done, our mRNA leaves the nucleus and goes into the cytoplasm. So our mRNA goes out the factory and goes into the cytoplasm here. And then when our mRNA leaves our nucleus, our DNA strand slam out again. Our DNA strand slam out again, it will close again, like this. So this is our transcription. So this is our transcription step. We done our first step. So now I wanna tell you what is the translation. So we don't need our DNA strand now. Just let me move here. So just I need our mRNA now. Our mRNA now in our cytoplasm. So our mRNA goes into the cytoplasm and fight the ribosome. And our ribosome, it comes with 2 pieces. So when lives into the bottom, the top half comes in, and our mRNA gets pulled through the ribosome and allow to read it, but not like by one. We read our mRNA by group of 3 that we call them codon. So on the other hand, our tRNA carried our amino acid and has an anticodon in the bottom on it. So in our mRNA here, so here, like for example, in here we have UCA. Our anticodon should be AGT. In every single time you have a new protein, but always we have same sequences. So as I said, our tRNA comes and has an anticodon on it in the bottom. So we should read our mRNA by group of 3 that we called codon, as I said before. So but our first sequence it's always same, and it is AUG. It is started from AUG. AUG means, so this one, it was our template strand, AGTA. So I said AUG. AUG, A means green, U means black, and G means red. So this is my mRNA strand. In here we have a black, orange, green. So this one, it's not AUG. So let's start and read the next group of 3. This one is orange, green, black. This one is not AUG as well. So let's move on and read the next group of 3. Green, black, and red. This is AUG. This is exactly what I want. So this is our AUG. So I will start reading our mRNA from here, AUG, and the other hand, our tRNA comes and has an anticodon on it. AUG, this is our codon. So our anticodon for AUG should be UAC. So this is my tRNA and my codon is AUG and my anticodon is UAC. So my tRNA comes and plug into my mRNA and drop the amino acid here, and they join together and drop the amino acid here, and then the tRNA leaves and go and find another mRNA to bind Yeah. So let's show you here. So this is my mRNA, this is my AUG, and this is my tRNA. My tRNA has an anticodon on it, UAC, and this is my amino acid. The tRNA comes and plug in and join in, and then drop the amino acid here, and then the tRNA goes and find another amino acid to bind it. So my next codon after AUG here is, after AUG we have a GUA. So let's find together GUA. This is my tRNA GUA, and our anticodon should be CAU. So our tRNA comes and plug in here and drop our amino acid here, and then our tRNA leaves and goes and find another amino acid to bind it. So my next group of 3 after GUA is ACG. So let's find our ACG. CGG. CGG. I should find CGG. Okay, here. This is my CGG, and my anticodon should be GCC. Okay, my tRNA comes and plug in, join it, and drop the amino acid here. It shows it white candy. Drop the amino acid here, and then the tRNA leaves and go to find another mRNA to join it. My next codon, it should be, okay, here, U, and my anticodon should be AAA. So the tRNA comes and plug in and drop the amino acid here, and then tRNA goes and find another amino acid, another amino acid. So my next codon is AGG. AGG, my tRNA has anticodon on UCC. It comes and plug in and drop the lighter here, drop the amino acid here, and tRNA leaves. So we will continue it until when? This is the question. So we have a tree. So we have a tree codon that we call a stop codon: UAA, UAG, and UGA. So our next codon for here is UAA. This is our UAA, and our anticodon should be AUU. Our tRNA comes and drop our amino acid here, and then our tRNA leaves and find another amino acid. So we continue it until we arrive here, AUU. Here, AUU. So when we arrive in our stop codon, which was UAA in here, we are done, and we continue our reading our mRNA until our protein change gets longer, and this is our translation, and that's it. Translation means translate one language to another language. We translate our nucleus language to the protein language, our information language to the protein language, our mRNA language to the protein language, and this is the transcription. So now we know what's the meaning of transcription, what's the meaning of translation. We already built our DNA strand, our complementary strand, and template strand, and mRNA strand, and we know what is the mRNA, what is the tRNA. And for now, I want to talk about mutation. What's the meaning of mutation? Mutation means change protein. In general, if we have a change protein, it doesn't work. But if we have a slightly change, it still work. And so that's why we have a different color for hair, or we have a different color for our eyes. So the question is why the mutation it happens. They have a different reason for the mutation. First of all, when we make our DNA or our mRNA strand, maybe we will have a mistake on it. So that's why I will recommend that you, when you build your mRNA or DNA strand, please double check, recheck your strand, and make sure to fix it correct. Because if you don't fix it correct, you will have a trouble on it. So because of the mistake, our copy of our DNA, our mutation will be happen. So if our mutation happen in our somatic cell means our regular cell. If our mutation happens in our somatic cell, it's an important cell. Our cell will die simply, and that's it. And if our mutation happens in our somatic cell, but it's happened in our growth cell, some of our growth cell will grow uncontrollably, but the reason for the cancer will occur. And if our mutation will happen in sex cell, all of our new child cell has this trouble, and so that's why it should be very dangerous. So the another reason for the mutation, it should be environment influence. The reason for the cancer, I can mention the smoking, UV rays, and radioaction as well. So there are two main divisions of single base mutation. First, point mutation, and the second one is frame shift mutation. What's the meaning of point mutation? Point mutation means substitution. For example, in our mRNA strand, if we have a AUG, if we substitute AUG, if we substitute the G with C, then we have a AUC, but we still can make our protein. So for example, here, let's take a look together. This is my mRNA strand, and this is my template strand here. I'm going to substitute number 7 codon here. Let's count together. 1, 2, 3, 4, 5, 6, 7. I'm going to substitute adenine with, for example, guanine here. I'm going to substitute the green one with the red one here. For example, like this. Okay, if we substitute the green one with the red one in our mRNA strand 1, 2, 3, 4, 5, 6, 7, instead have a uracil, in here we will have a cytosine, we will have a C here. Instead of U, we will have a C here. But it's not a big deal because we can still make our protein strand, and we can make our protein. So that's why this is the least dangerous mutation that we have. The other one, the second one, is frame shift mutation. In a frame shift mutation, instead the substitution, we have addition or deletion. It means in DNA strand, like here, we should remove like number 7 codon here. If I remove number 7 codon here, then what will happen in our mRNA strand? In mRNA strand, it doesn't have the uracil anymore. Okay, so let's read our mRNA strand together. I said our first sequence was AUG. It means here AUG, and our second code was GUA, but here after AUG we have a GAC, and then we have a GGU, UUA, and GGU and AAU. And I said just we have 3 stop codon, and it was UAA, UAG, and UGA. And in here we doesn't have any stop codon anymore. So that's why we cannot stop our reading our mRNA. So that's why it doesn't work anymore, and so that's why we cannot make a protein. So that's why this is the much dangerous mutation that we have. And also we have another mutation that we call silent mutation, that it happens. So for example, and this is our mRNA strand, and I said we started with a group of 3 here, AUG. We started from AUG here, but after A we have a 2 codon, right? So our silent mutation, it happens in this area, in this non-codon area. So the codon is not useful for us. It's like garbage. So if we substitute this codon with anything like CVG or anything, it doesn't matter. If we substitute those, we still can make our protein. So that's why we are good. And for the finally for the last mutation that I want to mention is missense mutation. And missense mutation means if you have a change in within your protein, so it's going to be totally screwed up, and this is will happen very rarely. So this is all the information that I wanted to explain for today, for the protein synthesis, for the mutation, and yeah, that's it.